All right, welcome everyone. It's actually afternoon, not morning. My name is Rudolph, and I'm here on stage with Mo from Red Hat. I'm from Boston Children's, and I think we took the idea of micro talks a bit too seriously, because I think we only have 2 slides, or 3 slides. But I'm going to ad lib a little bit. We're here to talk about this project that we've been working together on for about 4 or 5 years now. And it's called ChRIS, and it used to stand for Children's Research Integration System for Children's Hospital, right? Boston Children's Hospital. But we kind of realized there's nothing really children specific about it. And there's nothing even specific in Boston Children's specific about it either. So we just called it ChRIS. Now it just is ChRIS, which means the ChRIS Research Integration System. But I was kind of hinting that I'm at Boston Children's, which is where I am. I'm a researcher there, kind of neuroimaging. And there's a huge gap in medicine, which you may or may not be aware of. And that is, I think we like to think that medicine is pretty up there, pretty advanced with computing. The reality is, it probably isn't as up to the forefront as we might think it is. There's a lot of sophisticated equipment, but there's very little value added to any of the data that is collected clinically by any kind of computation, any kind of automation. It really doesn't exist. There are lots of reasons for this, and I can talk at length about why I think this is the case. But it really is true. We have human experts that look at data, and that's almost the whole story. It really doesn't do much beyond that. And it's been a problem for a very long time. And we live in this age of AI now, this age of AI hype, I almost want to say. I can say that because my background was in AI, so I can say what we're doing now is a lot of hype around AI. And I often think that folks have gotten the idea that before AI, computers did nothing. That before AI, computers just ran Excel or a web browser or an email client. But the fact is, we've been having scientific software for 50 years plus. And why hasn't this huge library of scientific software flowed into more industries, especially in medicine? So the idea of ChRIS really was one bridge that we were developing to cross this huge gulf, right? How do we get research computational research that folks like myself might develop in the lab, out there in clinical service where it can make a difference? So think of it as a bridge. We have a picture a little bit later. But doesn't really tell you much, right? But what is ChRIS behind the scenes? Well, it's kind of like an Uber scheduler, container scheduler, is how I would describe it, with a very friendly front face. And it was geared to make researchers who don't know much about programming, right? Even though they do computing, they might not know what Docker is. They might not care to know what Docker is. How do we get folks like these to get their code out there where it can be useful? How do we connect that code to a clinical service where it can be used by people who don't even care what happens behind the scenes? So that's what we're trying to do. So it is a completely through and through open source kind of system. It supports at its back end a whole bunch of environments like Docker, Docker Swarm, Podman, Kubernetes, OpenShift. And the idea here is if you are developing something, you don't need to care about Podman. You don't need to care about what is OpenShift or Kubernetes. You just write your app. And ChRIS will help you. It'll give you this friendly way to, with very little extra work, have your app containerized. And now with no extra work, you can run this on any number of backend environments. So one of the things so the kind of things we're trying to do at the moment here for the next following year is we're looking at exploring new backend environments that we can bring into this kind of ChRIS ecosystem. Stuff like Minikube for like edge computing. I should take a step back and say our idea of containers in ChRIS, what we've spent a lot of time doing is the idea of a workflow of containers. Right? It's not that you put all of your analysis in one big container and run that. You keep your containers as little tiny things. One that just does image conversions, one that just strips out tags from some XML file, one that might run some kind of AI compute. These live always as their big separate containers. But what ChRIS will do is we'll bring them together for you in one unified experience where every container can actually run in a different environment at the same time, within the same workflow. So we're looking at cubifying ChRIS to put in a mini cube. And we're also doing something which I think Mo can get.
Hi, I'm Mo Duffy from Red Hat. These are just two projects now we're looking at starting up in ChRIS. We're actually participating in this round of outreaching, and these are two of the projects that outreach interns will be applying to. I'm also interested in working with grad students, if any grad students here are interested, on the HIPAA Safe Cloud project. But I'll just start with the project we call ChRIS in a Box. We've been doing a lot of work over the past year getting ChRIS fully OpenShift-ified. And one of the advantages that the completion of that work will give us is that we have the opportunity to then create a microchef version of ChRIS, which we hope at some point could help organizations maybe with not a lot of computing resources use an edge computing device to do some local compute and then potentially ship additional workloads, say to Boston Children's ChRIS, for more computation if we want to do that kind of infrastructure sharing. The other project that we're looking at starting up right now is the Safe Cloud. So this is something that Oren mentioned earlier this morning. In the past, ChRIS has done work with the multi-party compute algorithm. We have an MPC plugin. This is sort of the next stage of that compute. We're trying to make it so that we can actually store data in MOC in a HIPAA-compliant way to not just enable ChRIS, but other projects that may have that kind of restriction on the data. So this is something that we're actively trying to sit down and figure out, okay, what are the next steps? We have the MPC plugin now, what's next? And that's the last slide. Oh, yes, and then the demo.
Okay, we'll see if this works quickly. This is just a quick teaser about the actual workflow that is live. And what I'm going to just show here, I'm going to click on this link, I think. Oh, okay. So there are a whole bunch of steps. The blue subway stops on top. Each one of those is a separate container that ChRIS will schedule, and it will provide this kind of, oh, okay, I guess no.
Did you have it?
It's just a link. Oh, okay. So here it's giving this like super fancy feedback to a system that's running on its own right now, collecting an image. It is now going to push it to ChRIS. Each of these is going to be a separate container. Now ChRIS is running its backend algorithms, right? This is one that's trying to find landmarks using AI. And the point here is to simplify the process of just measuring a leg. You want to find how long a leg is. Because oftentimes, there's a difference in leg length, and it takes a clinician 5, 6, 7 minutes to do this. Right now in clinical practice, what they do is they sit with a mouse on their screen and click here, and visually click down to the next one, look what the UI tells them the length is, write it down on a piece of paper, do the next one, the next one, the next one. That's the workflow in 2023. So here we've automated this kind of super simple, but non-existent benefit that we're trying to add to the system.